Bright Tuty. Every student matters.
Hello everyone. Today we're going to start with understanding quadrilaterals. So first of all, we will do the introduction of the chapter. In this we are going to learn first some of the closed figures, open curves, closed curves, and then polygons. So let us start with the first topic, that is simple closed figure. Here comes the definition that says in simple closed curves the shapes are closed by. So pay attention here, it should be a closed shape by line segments or by a curved line. That means the figures or the shapes or the curves which are closed by line segments or by a curved line. That means they should not be crossing each other, they should be simple lines. So for example, we can take the first one, which you can see is a triangle and it has three sides, three angles, three vertices. You can see all are closed at the end and it is formed of line segments. The second comes a rectangle that you can see it is also made up of line segments and it is closed at all the ends. The next example is of a circle. Circle is also a simple closed figure which is closed everywhere. So this is what known as a simple closed figure. Let us now come to the next one, which is an open curve. Here comes the definition that says the shape which is not closed by line segments or a curve is called an open curve. As the name suggests, it will not be closed at the ends. So here are some of the figures for open curve. As you can see, this triangle which is left opened from here. Also the next figure and the third one. These three are open curves. Let us move to the next definition, that is closed curve. Here comes the definition. A closed curve which does not cross itself is called a simple closed curve. That means the curve would be simple, it will not cross itself. So for example, here are some of the figures. As you can see, figure D first, the curve is crossing itself, as well as in E part the curve is crossing. The curved lines are crossing each other. So these two, that means part D and part E, are not simple closed, but they are known as closed curve. But these are not simple closed curve. Except D and E, we can see all other parts are closed as well as simple. So this is the main difference between a simple closed curve and a closed curve only. So all of these are known as closed curve, but D and E are not simple closed curve. Let us move to the next one. Here is a table given to you and you have to match the following. Like first is given a figure and you have to match the type of it. So let us see all the options. Now the first option says simple closed curve. So it is not at all closed, as you can see in the figure. The second option is a closed curve, that is not simple but it is not closed. The third one, simple curve, and that is not closed. So yes, C should be the option for the first one, and D is not a simple curve, but yes, it is a simple curve. No lines are crossing here. The second one is given as like this. Now they are asking us, we have to match this with the type of it. So when we see the first option is simple closed curve, so it is not simple because the lines are crossing each other, as you can see in the diagram. So the first option will not be there. The second one, a closed curve, that is not simple. So yes, the second one as shown here is not a simple closed curve because the lines are crossing. Now the B part, a closed curve, that is not simple. So yes, it is a closed curve but it is not simple. So B option will be there, its type. The third one is simple curve, that is not closed. So we see that it is a simple curve. No, it is not a simple curve. So C option will not be there. The last one is not a simple curve. Yes, it will be there. So D is the correct type for second one. Now see the third figure where this is shown and they're asking a simple closed curve. So yes, it is a simple closed curve. So A will be its type. A closed curve, that is not simple. So it is a closed curve and it is simple. So B is not its type. The third one, simple curve that is not closed but it is a closed one. And the last one, not a simple curve. Yes, it is a simple curve, so this will not be its type. The last one, the fourth one, where you can see the lines crossing, so definitely it is not going to come under simple closed curve. The next one is a closed curve that is not simple. So yes, B is its type. C, simple curve that is not closed, but we see it is closed. So C will not be its type. The last one, not a simple curve. Yes, it is not a simple curve. So it will be its type. So this is how you're going to match them. Let us go to the next one. That is polygons. Polygons is the main topic that we are going to discuss in the class today. So here comes the definition for polygon. It says a simple closed curve. So first of all, simple closed curve. So we have already discussed what is a simple closed curve. The lines should not be crossing each other. The curve should not cross each other. Also, it should be a closed one, made up of only line segments. Earlier in simple closed curve, we discussed that it should be closed by either line segments or by a curve. But here in polygon, the figure should be a simple closed curve and it should only be made up of line segments. So it will be known as a polygon. So we can take some examples. Here comes three figures that shows that these are polygons, because we see that lines are not crossing each other, so it is simple. They are closed everywhere, so it is a simple closed curve. And as we can see, it is only made up of line segments. All three of them are polygons and they are made up of only line segments. Next comes these three curves which are not polygons, because we see this one, the last one, is not even a closed one. The first and second one are closed but the lines are crossing each other, so these are not polygons. So what's the definition of polygon and what the conclusion that we have made? That it should be a simple closed curve, the first thing, and there should not be any curve or curved line in that. It should only be made up of line segments, so the figure will be known as a polygon. So here poly means many and gon means sides. So you see, a figure made up of many sides is called a polygon. It should be a simple closed curve with only line segments. So this is the main thing that you need to keep in mind, that it should only be made up of line segments. Now let us go to the next one, which is classification of polygons. So suppose I draw a triangle here. As you can see, it will have three vertex A, B and C. So it has three sides, AB, or the line segments I say AB, then we have BC and then we have CA. So these are the three line segments. So yes, it is a polygon because it is simple and made up of three line segments. So this is known as a polygon of three sides. Right? Now if I go with another one, I can make a closed figure with four sides, as you can see. So it is a polygon with four sides because it is a simple closed curve. Right? Now if we go with five sides, so we can draw with five sides also. So I am drawing it 1, 2, 3, 4 and this is the fifth side. So we can name it as A, B, C, D and E. So we see this is a polygon having five sides. Similarly, we can draw with 6 sides, 7 sides, 8 sides, 9 sides and so on. This one that I have drawn is a polygon with 6 sides. So what we will do is, we will classify the polygons based on the number of sides. So n will denote the number of sides. So here is a table for you that you can see, where number of sides is written and then the classification, what we call that figure, that name is written, and then the sample figure is given to you. Let us have a look on them one by one. The first one having three sides, it will be a triangle. Here is the figure for triangle. Then if four sides are there, it will be known as quadrilateral. As in the triangle, tri means 3, quadrilateral, quad means 4. That means a simple closed figure with four sides will be a quadrilateral, and this is the sample figure for you. Now if the number of sides is 5, the figure will be known as, or the curve will be known as, a pentagon. Here is the sample figure. Similarly, if it has 6 sides, it will be known as a hexagon and it will be like this. Now the seventh one, if it has 7 sides, it will be known as heptagon and the figure is as shown. Similarly, for 8, 9 and 10 sides, if we have the polygon having 8 sides is known as octagon, with 9 sides it is nonagon, and with 10 sides it is decagon. So if it has n sides, we call it as n-gon. That means if it has n sides, generally we write is n-gon. Right? So this is how we classify the polygons based on number of sides. Let us now move to the next topic, which is diagonals. So what is a diagonal? How do we define it? You might have done in earlier classes also. So let us define it. Here is the definition. It says a diagonal is a line segment connecting two non-consecutive vertices of a polygon. So the most important thing to focus here is two non-consecutive vertices. So suppose I have drawn this figure for you. It is a quadrilateral, right? So let us name it as A, B, C, D. So here we can see it has 4 vertices. So for the vertex A, the adjacent one are B and D. So it will form a diagonal with C. So we will join A with C. So AC is known as the diagonal of this figure. Clear? Or the polygon. Now similarly for B, it will be towards D. Like when we join B and D, the another diagonal will be drawn for this quadrilateral. So let us take a proper example. As you can see, a quadrilateral. I'm naming it as A, B, C and D. Now we can join A with C. Why A is only joined to C? As according to the definition, diagonal will be a line segment that connects two non-consecutive vertices of a polygon. So for A, B and D are adjacent to A. So we can't join them and form the diagonal. That will form the side of this polygon. The diagonal will be formed by vertex A and vertex C. Similarly, the second diagonal will be formed from B to D. Clear? Let us go to another figure now. Here comes a pentagon. So let us name it first. A, B, C, D and E. So here it has 5 vertices, 5 sides. It is a simple closed curve. So it is a pentagon. We call it as a pentagon as discussed earlier. Now we have to draw the diagonals of it. So from vertex A, we see E and B are adjacent to vertex A. So from vertex A, we can draw diagonals to point D as well as to point C like this. Now from point E, if we see, from point E, we see A and D are the adjacent vertices to vertex E. So we can draw the diagonals to B and to point C. Similarly, if we go to point B, A and C are adjacent to it. So we can draw the diagonal to E, that is already drawn, and then from B to D we can draw. So as we can see here, there are 5 diagonals that we have drawn here of the pentagon. Now, how to calculate the number of diagonals? Now, the general rule is n into n minus 3 divided by 2, where n is the number of sides of that polygon. So here we see how many sides we have, 5 multiplied with 5 minus 3 divided by 2. So we get 5 multiplied with 2 divided by 2, and that gives us 5, which is the number of diagonals in the pentagon. Okay, why are we doing this, that every time we are going to do n minus 3? The reason here is the vertex A, if we consider the first vertex A, it can't form the diagonal with itself. Also, it can't form with E and B. So for every polygon, you will find a vertex that will not form the diagonals with 3 of them itself and the 2 of the adjacent vertices. So that's why we write n minus 3, and it would be applied to all the polygons. Let us now go to the next topic. That is interior and exterior of a closed figure. So I know that you have already done it in detail. Let us have a quick recapitulation of it. So suppose I draw a quadrilateral here like this. Let us name it as A, B, C and D. Now I will mark some points. Let it be E here, F here, then G here and H here. The part which is inside this boundary of the quadrilateral like this that I am shading, this one is known as the interior of the polygon, and the portion outside it will be known as the exterior, as I am writing here. So now if I ask you what are the points in the interior of ABCD, the points are E and G, which are in the interior of it, and in the exterior the point F is there. So point F is in the exterior of it. So this is a very simple thing that you can all keep in mind. Let us now go to the next one, that is concave and convex polygons. So this is something really important to keep in mind. Let us first discuss convex polygons. So here a convex polygon, let us first discuss convex. A convex polygon will have all the interior angles. Their measures will be less than 180 degree. Suppose I have given you a figure like this. So in this we see each angle is less than 180 degrees. Here these 5 angles, right? So suppose we take this. In this also each angle is less than 180 degrees. So these kind of polygons where all the interior angles, they are measured, each and every interior angle will measure less than 180 degrees. Other than this, the polygons are known as concave. Suppose we draw a polygon like this. I have drawn it like this. Let us name it as A, B, C and D. So we see these 3 angles are definitely less than 180 degrees, but if we talk of this angle, this is a reflex angle which is greater than 180 degree. So these type of polygons are known as concave polygons. So in our lecture we are going to mainly focus on convex polygons only, right? But the difference must be clear to you. Let us now move to the next topic. So as you can see in A and in B, there are some polygons given. Okay, now what about the A part? In this, these are convex or concave. So as according to the definition that we have seen, the interior angle should measure as less than 180 degree. So in A part, all these 3 figures are convex polygons, and the other one in B part, they are concave polygon, because as I can show you, this angle is more than 180 degree. Similarly this angle in this, so like this, the angles are more than 180 degrees. So these are known as concave polygons that are drawn in B part. Let us go to the next concept, that is regular and irregular polygons. So what are regular polygons? If we talk of regular polygons, it means 2 things: equiangular and equilateral. Equiangular means all the angles are equal in that. Equilateral means all the sides are equal. So suppose we take an equilateral triangle ABC. Let this be A, B and C. So this is an equilateral triangle. Each angle will measure 60 degrees and all the 3 sides are equal. The symbol is for equal sides. Right? Now one other example that you people can think of which have the all same sides and having the same angles is a square. So if we think of a square, it has all the 4 sides as equal and each angle is equal to 90 degrees. Right? So these are known as regular polygons. What about irregular polygons? In irregular polygons, we will not have the sides or angles equal. So suppose if I talk of a rectangle, let this be a rectangle ABCD. In this rectangle, we see that opposite sides would be equal. Each angle is of 90 degrees. So it is only equiangular but not equilateral. So it is an irregular polygon. Right? two conditions must be satisfied. If something or some polygon is only equiangular, it won't be a regular polygon, or if it is equilateral, only equilateral, then it will not be a regular polygon. Equiangular and equilateral, these two conditions are mandatory for a polygon to be a regular polygon. Clear? Let's go to the next one, which is angle sum property. As you all know that in a triangle, you have studied angle sum property, that the sum of three angles, let us name the triangle as ABC, the sum of three angles, angle A plus angle B plus angle C is equal to 180 degrees. This is angle sum property in a triangle. The same concept we are going to apply to quadrilaterals. Let us draw a quadrilateral now. So suppose this is a quadrilateral. Let us name it as A, B, C and D. Now I will draw one diagonal that can be from A to C as well as it can be from D to B. So let us draw it from A to C. Now we see that this diagonal divides this quadrilateral into two triangles, the first one and the second one. Let us name the triangles. The first triangle is triangle ADC and the second triangle is triangle ABC. So let us name the angles first. So let me name 1, 2, 3, 4, 5 and 6. These are 6 angles that we can see here. So in first triangle ADC, we see that the sum of angles 1 plus 6 plus angle 5, this is equal to 180 degrees. Let us name it as our first equation. Now in triangle ABC, we can write angle 2 plus angle 3 plus angle 4 is equal to 180 degrees, again using the angle sum property. So we are applying the angle sum property of a triangle to the quadrilateral. Now if we add these two, so here on the right hand side we will get 360 degrees, angle 1 plus angle 2. These two will form angle A. So instead of angle 1 plus angle 2, I am writing angle A plus, now angle 6 is there, angle 6 is angle D, plus angle 3. Angle 3 is what angle? B here. So it will be angle B plus, now we have angle 4 and angle 5. If we add these two, we form the angle C. So we can see that the sum of four angles of a quadrilateral is 360 degrees. So this is angle sum property of the quadrilateral. So we have deduced this from the angle sum property of the triangle only. So this was quite easy to learn. Let me recapitulate it again. So what we have done, we have drawn a quadrilateral. We divided into two triangles by drawing one of its diagonal, let it be AC or DB, you can try with any. The two triangles, in each triangle we have applied angle sum property of the triangle, and then using those two equations we got that the sum of four angles of a quadrilateral is 360 degrees.